Good day, everyone. Welcome back to learning to understand electrical principles. Now that you've actually learnt about how circuits work and their properties and all these things, let's solve a question. So, here we have a circuit, and we are asked find find the voltage at DE. So we need to find the voltage drop that occurs along DE. Now, I'm going to show you how the best way to solve circuits. A lot of people, I think, make the mistake of redrawing a circuit, which takes time. And in some of the papers I've done before, you don't physically have the time to redraw a circuit. So I'm going to teach you now my methods for actually understanding the circuit without needing to redraw and solving it. So before we even start looking at what we're trying to find out, let's figure out what this circuit is. So now we're going to color in every single node. I'm going to start off with an orange node. So this is our first potential. Everything here has the same potential as the source, 660 volts. And then I'm going to take this, and this is the red section, purple, no, that's not purple, this is, and then green, and now let's get a blue. You know what, let's take a blue, and that goes, whoop, that was terrible. That goes across here. Now I'm going to highlight this in a nice blue. So now we can understand what the circuit potential looks like, where the potential keeps changing. The issue is now we need to see where the current is flowing, because as you notice, DE is an open circuit. So the branch that contains DE will actually have no current flowing in it. And where does this branch start? Well, if we actually follow our current, it goes here, and you see it splits, and then it goes around here, and now this is the branch where it moves into DE. But since there's no current going in there, that means I'm just gonna keep this on. Now notice it's still purple because it still has the same potential, but it's gonna have no current flowing through it. And now you see this current from back here meets up with this current again because it's circled round. So then here we should have the total current coming in, because if this was our IS, and then it's split into, let's call this I1 and I2. So this split, and then it came back here to be IS again. And then it's not, is it going to go down this path? No, because once again DE is there. So the current's not going to go there. It's going to go up here and back into the thing. So now we can look at the circuit. Now we've described all the relationships in the circuits. We've seen the current, we've seen the potential changes. Let's look at finding the voltage across DE. So we want to find the voltage across D. And now since it's D first, we're going to put the plus on the D. And we're going to go minus D. And this is going to be our voltage drop. So you notice that the potential, the E potential is pink or purple. E is this purple node, while D has the same potential as this darker blue node. So if we can find the voltage at this node here and the voltage at this node, well then we should be able to find out VDE. Now, there is another thing we could do, because with circuits there are multiple options that we have. The other option we have is we could do a KVL. If we find the voltage across the 12K, the 3K, and DE, remember, the 1 kilo ohm and the 2 kilo ohm have no current going through them, so they're going to have no voltage drop. So if we can find the voltage drop across the 3 kilo ohm and the 12 kilo ohm, then we can do a KVL. So, first of all, to actually get the voltage, we're going to need to look. So, we can see that this red line and this pink line are branches, because the current doesn't split in these lines. So they're going to be a branch. So, if this is a branch and this is a branch, that means this 10 kilo ohm and this 2 kilo ohm and the 3 kilo ohm are all in series. So we can put this relationship down now. The 10K, the 10K, the 2K, and the 3K are in series. Now, you see that this series branch here with the 10, 2, and 3 have the same input potential from the orange line, and they have the same output potential in the green line. That means this 10, 2, 3, we know that 10 plus 2 plus 3 is going to be 15. So I'm going to call this the 15 kilo ohm. The 15 kilo ohm is in parallel with the 30. And now we see that these two join up to go to the green line. And this green line then goes to this blue line. And since this blue is not shared with anything else, okay, it's shared with this one here with the D, but since it's not shared anywhere else, with anywhere that has current flowing, this is in series. And therefore, the 12K is in series with these two, with this parallel branch. And it's in series with the source. So, what are we going to do with all this information? Well, let's think about this. We need the voltage at E, or we need the voltage across the 3 kilo ohm and the 12 kilo ohm. To get the voltage in this 12 kilo ohm, how can we do that? Well, the voltage in the 12 kilo ohm, so I'm going to call this V12K. Voltage in the 12 kilo ohm is going to equal to the total current, since that's what's flowing through it, times 12 kilo ohms, because that's its resistance. So that's how we would calculate that. But to get this current, we need to know the total resistance of the circuit. Okay. So how would we get the total resistance of the circuit? Well, we just discussed that these are in series and those are in parallel. So if we plug in the equation, 1 over RT is going to equal to 1 over 30 K plus 1 over 15K, because the 15 is the 10 plus 2 plus 3. Well, that'll give us 1 over 30, don't forget the K, plus 2 over 30. And then we can get that this is going to be 3 over 30 kilo ohms. And if we invert the RT, we'll get 10 kilo ohms. Oh, sorry, this is not RT. My bad, my bad. This is R parallel. Be careful. These mistakes can cost you sometimes. So always check your work. So you see, this is my parallel circuit. Now, the RT will be equal to 10K plus the 12K, and that will give me 22 kilo ohms. Now, to get our I total, we'll say IS, well, let me actually put this, over here. So our IS is going to equal to our voltage total over our resistance total. That's Ohm's law. And that'll give us 660 over 22K. Now 660 divided by 22 will give us 30. And this will be milliamps. So what we're going to end up getting is 30 M milli times 12K. And this will equal to 36. Sorry, 360 volts. Now, what we could have done, instead of using the Ohm's law for I times R, we could have said instead, this is equal to the voltage total times RR12, okay, over RRT. We could have easily done that. So this 3 kilo ohm, we need to find that now. I can find the current flowing through this branch times the ohms to get the voltage. The other way to do it would be to get the total voltage in this branch and then do the voltage divider rule. And now the best way to get the voltage in this branch so the best way to get the voltage in this branch would be to just say the total current times the resistance parallel, which will give me my voltage, and then I'll do a voltage divider. You can try that way at home. The way I'm going to do this is I'm going to use Ohm's law once again. I'm going to use a current divider rule, and then I'm going to get the voltage through here. So, how am I going to do this? I'm going to say I1 is equal to IS RT over, now remember this is an RT, this is R parallel, over the series branch. So that's going to be R15. Okay. And this will give me 30 milli times 10k over 15k. And what this will essentially give me is the current going through here will be 20 milliamps. The current going through here is 20 milliamps. And then I'll say the current going through the 3 kilo ohm will be 20 milliamps because it's in series. So our V3K is going to equal to 20 milli times 3K. That's going to give me 60 volts. And now that I've done that, I can use my okay, cut now. Okay, go back. Okay, now that I've got this, I can use my KVL. So that's the plus, that's the minus. That'll be our voltage drop. That's the plus, that's the minus. And that's going to be this way. So what we're going to get is our equation. You notice all three arrows are going the same way. So it's going to be equal to V12K plus Y. Please cut, please cut. Okay. Okay, I'm back. So V12K plus V3K plus VDE is going to equal to 0. And when we look at this, so the 12K is 360 plus 60 plus VDE is going to equal to 0. So if we take VDE and we take all the rest to the other side, our total voltage is going to end up being negative 420 negative 420 volts. Now, why is it negative? Well, if we look back here, the higher potential was coming at this side. This current, the higher potential of the circuit is here, because you can see that this point will have the lowest potential in the entire circuit, while this will have the highest potential. I mean, not the highest, but this will have the higher potential. So E should have the higher potential than D, so this arrow should be swapped. But because we took D to be the positive, this answer is going to have a negative value. Because also, once again, this negative means that this arrow is flipped, which means this arrow goes against the direction of the loop. Now, the second question we were asked is, what was the power delivered to the 30 kilo ohm? So, power, I don't think I really spoke about this, but power is equal to V times I. V times I, which is also equal to V squared over R, which is also equal to I squared R. And that's all just applying Ohm's law to get different formulas. So, we're going to look at this 30 kilo ohm and we're going to say, okay, well, we know what I1 is now, we know what the I source is. Is there a way to calculate the voltage across here? Because since we know the resistance already, it's probably best to calculate with either not to use the standard formula V times I, because both of those are unknown, but to use either the V squared over R or I squared R. And now looking at this, if we wanted to get the voltage, we need to use our I value, our I1, times it by the 15K to get our voltage, and then times that to here. Or we could say I source minus I1, which will give us I2, because that's the KCL. And then we can use that to get our I squared times R. So let's use the latter one, and we're going to say that the current going into a node is equal to the current going out the node, which means that I2 is going to equal to 0.3, I mean not 0.3, it's going to equal to 30 milliamps minus 20 milliamps. And that's going to be 10 milliamps. And we're going to say that the power of the 30K is going to equal to I squared, well, it's going to be I2 squared not over, it's going to be I squared R30. Okay. So this is going to be 10 milli squared times 30. And I believe this should give us 300 milliwatts. Let me just get the calculator and find out. So if I were to say 10e negative 3 squared times 30e3, Oh, my bad. This will be, instead of 300, it's supposed to be 3000, which means that this would end up being equal to 3 watts. And just like that, we've ended up solving the circuit by breaking it up. My advice when you're trying to actually solve circuits is follow a pattern. First, you're going to look at the circuit and then highlight all the nodes. Highlight all the nodes, all the branches, and break your circuit up into color so you can understand what's going on without needing to redraw. Then look at what you're actually trying to calculate. So find the value, like find DE, look at DE, see how is this going to be orientated, and then look what do you need to find. And sometimes you can look at multiple things. Like I can look at the one path. I only used the one path to get there. There are multiple loops I could have used. There are multiple different methods. So try and look at what options you have available and walk backwards from what your answer and see, okay, well, I need DE. Well, to get DE, I would need to do a loop. And that loop would need to, let's say, include the 12 kilo ohm and the 3 kilo ohm. Well, how would I get the 12? And then how would I get the 3? And work backwards until you can get something you can actually solve easily. And do that, or that's basically the best way to get through these circuits is break them down into their components and then work backwards from what you're trying to solve and see, well, I don't have this variable, how do I calculate that? And that's how you solve circuits. Thank you for your time.